Hey everybody, welcome to another college algebra video. We are starting chapter 8, section 1, systems of linear equations with two variables. This section is going to be broken up into two videos. This is all the objectives that are covered in this entire section. We are only going to do, for this video, we're going to do the first three. We're going to talk about how to know whether an ordered pair is a solution. Then we're going to talk about the two methods of solving: substitution and addition. Okay? So the first thing to talk about is, what is a system of equations, or a system of linear equations? And so all equations that are in the form ax plus by equals c are just straight lines, right? So if you have two equations, that's called a system, and you can have more than two, but we're only going to focus on two. And so a solution then to the system is the ordered pair that satisfies both equations in the systems, or an ordered pair, right? If you have at least one solution, you're called consistent. If there are no solutions at all, it's called inconsistent. And in the next video, we'll talk about what those look like. We're going to focus on the most typical thing that happens when you are solving linear equations, and that is when you get one solution, okay? So let's take a look at how you do that and what that means. So consider the system 2x minus 3y equals -4 and 2x plus y equals +4. And we want to know if the ordered pair 1, 2 is a solution to that system. So how do we determine that? What that means to be a solution, that means what? It works in both equations. If I take 1 equals x and I take 2 equals y, if I plug those in, I should get something that's true. In the first equation, I get 2 times 1 minus 3 times 2 equals -4. Is that true? Well, 2 minus 6 equals -4. Yep, that's true. But that's only for the first equation. Now I have to check the second one. And so I get 2 times 1 plus 2. Does that equal +4? 2 plus 2 equals 4. Yes, we know that's to be true. And so yes, 1, 2 is a solution. It's one answer. The answers for these systems of equations are not just an x or a y, but they're a combination of the two. Okay, so 1, 2 is a solution for the system. So how you determine if it is a solution is you simply plug it in. Plug in for x, plug in for y, but it's got to work for both equations. All right, so y'all try it. Pause the video. Here is the same set of equations, but now you're going to test 7, 6 and see if it works. Pause the video and try it, and then come back and we'll go over it together. Okay, so again, x equals 7 and y equals 6 in this ordered pair. And so we get 2 times 7 minus 3 times 6, and the question is, does that equal -4? Well, we get 14 minus 18, and that's -4. So yes, it works in the first equation, but that's not enough. We need to test the other equation too. 2 times 7 plus 6 equals 4. 14 plus 6 equals 4. Is that true? Absolutely not. 20 is not equal to 4. And so no. 7, 6 works for this equation, but it does not work for this equation. In fact, right, each of these equations are a line, and a line has infinitely many points. So there are infinitely many answers that work for the first one, but they don't necessarily work for the second one. There's infinitely many answers that work for the second one, but they might not work for the first one. A solution to the system has to work for both. Okay, so 7, 6 is not a solution for the system. Okay, it works for the first one. I can't spell, but it works for the first one, but not the second one. Okay? So that's how you test to see if an ordered pair is a solution, but how do we find the solutions? Well, there's two methods, and you're going to be required to do both methods. When you go to do the homework, when you go to do the test, make sure you read the directions, because I will tell you, solve it by this method or solve it by this method. And the reason for that is because when we get to more advanced systems, like in section 8.4, both methods don't always work. So you need to know both methods, and that's why I require you to demonstrate you can do them both. Okay, so the first method is called substitution. I'm going to let you guys pause the video now and write down the steps if you like, but I'm not going to go through them all together. The idea is this, that you solve one of the equations for one of the variables and you plug it into the other one. That's the idea. That's why it's called substitution. Okay, so let's do an example. Solve by the substitution method, 3x plus 2y equals 4 and 2x plus y equals 1. Solve either equations for one variable. So in other words, pick one of these two guys and solve it for one of the variables, x or y. It doesn't matter. This is your choice. And here's the thing. You get to make the decision. Once you make that decision, though, you're kind of stuck with it. So I'm going to choose the bottom one because it has a y with only a 1 in front, so I don't have to divide. And if I can avoid fractions, that's always good. So I'm going to take 2x plus y equals 1. And then what do I have to do to solve? I simply subtract 2x from both sides. And so I end up with y equals 1 minus 2x. And now I take that and I substitute it into the other equation. You can't substitute it back into the one that you already used because you'll get a mess. Well, you'll get something true, but it won't be helpful. All right. So here, instead of, if I told you y equals 7, you'd plug in y equals 7, right? Well, I just told you y equals 1 minus 2x. So we're going to plug that in for y. So we get 3x plus 2 times y. Y is 1 minus 2x, so plug it in. And that equals 4. And now we have an equation with only one variable, so we can solve it. 3x plus 2 minus 4x, distribute the 2 there, equals 4. Subtract 2 from both sides. Combine like terms. You get 3x minus 4x equals 2. So negative x equals 2. And so x equals negative 2. All right? So step 2 is to plug it in here. Step 3 is to solve it. All right? But this is not the answer, right? What do all of our answers for these look like? They're not just x equals, they're an ordered pair. So plug it back into the original system. What was the original system? We had 2x plus y equals 1, which we solved y equals 1 minus 2x. So plug it back in there. Y equals 1 minus 2x. And we plug in negative 2 for x. And so we get 1 plus 4, which is 5. And so the answer is negative 2, 5. That point works for both 3x plus 2y equals 4 and 2x plus y equals 1. Right? And you can check yourself by going back and plugging it into the other one if you want to. All right, that's not required, but if it plugged in the negative 2 here and I plugged in the 5 here, I'd get negative 6 plus 10, I get 4. So it does check. It's got to work for both, right? We already know it works for this one because that's where this came from. So that's the process of substitution. Okay? Pick one of the equations, solve it for one of the variables, and plug that in for the variable in the other equation, and then solve, and then go back and figure out the other variable. All right? So that's substitution. Here's a second system of equations. Y'all try this one, hit pause, try this one the same method I just used. Solve for x, solve for y, first or second, doesn't matter, but plug it in. And there's lots of different ways that you could do it, but there's only one correct answer. All right, so y'all try that and then come back and we'll go over it together. Okay, so again, you may have chosen a different way to do it, but I'm going to solve this one for x this time. Because again, x is by itself with no constant in front, and so that should be easy. I can just subtract 3y from both sides. And so I end up with x equals negative 3y minus 4, or minus 4 minus 3y, doesn't matter. Order doesn't matter there, okay? As long as you have your sign straight. And so then we're going to do what? We're going to take this negative 3y minus 4, and we're going to plug it in for the x in the other equation. So the other equation is 3x minus y equals 8. We're going to plug in for x. negative 3y minus 4, and now we only have y's, so that's easy to solve. Distribute the 3, you get negative 9y minus 12 minus y equals 8. Add 12 to both sides. Combine like terms, you get negative 10y equals 20. Divide by negative 10, and you get y equals negative 2. But now we have to come back and plug in to solve for x. So x equals negative 3 times negative 2 minus 4. X equals 6 minus 4, so x equals 2. So our answer is 2 comma negative 2. One answer. An ordered pair is one answer, a combination of x and y that works in the first equation, 6 minus negative 2 is 8, and works in the second equation, 2 minus 6 is negative 4. Okay? So that is the process of substitution. That's one of your two processes for solving systems. The second one is what's known as addition. Some textbooks will call this elimination. It's elimination by addition, so however you want to think about it is fine. Okay? And so what you do is you want both equations to be in the form ax plus by equals c. We're doing the opposite here. We're not trying to solve for one variable, but we want all the constants on one side and all the variables on the other. And then we want to line up either x or y so that they have non-zero numbers in front of them that cancel out. They're opposites. If one is 2x, the other one's negative 2x. If it's 7y, it's negative 7y. And then you add them together in order to create an equation of one variable. They kind of eliminate the other variable. Okay, so let me show you what it looks like. So you've got 4x plus 5y equals 3 and 2x minus 3y equals 7. They're already written in the right form. Okay, no big deal. All right, but now what we need is we need to be able to get the same number with opposite signs in front of the variables. Either in front of the x's or in front of the y's. Now, the y's have opposite signs, but 5 and 3 don't have anything in common. Where the x's don't have opposite signs, but 2 goes into 4 twice. And so if I just multiply the bottom by negative 2, I'll get 4 and negative 4. If I multiply the top by like a 3, then I'd have to multiply the bottom by 5, which is fine, but we try to make it as simple as possible, okay? So let me show you what I mean here, all right? We're going to take the 4x plus 5y equals 3. We're going to leave it alone. And then we're going to take the 2x minus 3y equals 7. We're going to multiply by negative 2. On both sides, distribute. This is where students make mistakes, all right? That negative 2 is being multiplied on both sides, which means every single term on each side gets multiplied by negative 2. So you get a negative 4x, a negative is a plus 6y, and then a negative 14. So 4x plus 5y equals 3 stays the same. Negative 4x plus 6y equals negative 14. Now you can see why we did this. If I add these two equations together, 4x minus 4x will be no x, and I have only y's. And that's what I wanted. Okay? So let's see what it looks like. If I add them together, I get 0x, 5 and 6 is 11y, and 3 plus negative 14 is negative 11. And then if you divide both sides by 11, you get y equals negative 1. Okay? Just like before, y equals negative 1 is only part of the solution. What do I need to do next? I need to go in and plug in to one of the other equations. It doesn't matter because I didn't solve one of them for anything. So I go back and plug into one of my other equations. If I plug into the first one, 4x plus 5y equals 3, I get 4x plus 5 times negative 1 is 3. 4x minus 5 is equal to 3. Add 5 to both sides and divide by 4. And so you get a solution of 2 comma negative 1. And again, if you really want to check yourself, then what you can do is you can go back and you can plug into the other equation. You don't have to do this, but you can go and plug it back into the other equation, which was 2x minus 3y equals 7. And you just do a quick check. 2 times 2 minus 3 times negative 1. 4 plus 3 is 7, you bet. So it does work. So the answer makes sense. All right, that's the addition method. Y'all pause the video and try it on this equation, try to solve by the addition method. You may have to multiply the top and the bottom equation by different things. It's whatever you can get to make things line up so that you have opposite signs but the same numerical value in front of one of your variables, x or y, doesn't matter which one. Pause the video, give it a shot. Alright, so in this case, there are no common factors between the x's or the y's. And so therefore, I'm just going to end up multiplying the top. I'm going to multiply, if I want to get rid of the y because they have opposite signs, I'm going to multiply by 3. 3 times negative 4 is negative 12. If I multiply by 4, 4 times 3 is 12. And so if I multiply those out, I end up with 9x minus 12y equals 24, and 8x plus 12y equals negative 16. Multiply, distribute all the way through. 17x plus 0y equals 8. Now this may bother some of you. 8 over 17, that must be the wrong answer. No, there's nothing wrong with getting a fraction. Fractions are perfectly legit. It's not going to be a lot of fun trying to solve for y necessarily because I've got to deal with fractions, but that's part of life. So now I go back and plug in. Let's plug in here for x. I get 2 times 8 over 17 plus 3 times y equals negative 4. 2 times 8 is 16 over 17. Since I'm going to have to be adding fractions, I need lowest common denominator. The lowest common denominator is 17. 17 times negative 4 is negative 68. Subtract 16/17 from both sides. And I get 3y equals negative 84 over 17. Divide by 3. Dividing by 3 is the same thing as multiplying by the reciprocal. And 3 goes into 84 28 times. And so I get y equals negative 28 over 17. So my answer is 8/17, negative 28/17. And I don't particularly want to have to check that because it's not a lot of fun plugging that back in, but you could check it in this equation if you needed to. All right. So just because you get a fraction doesn't mean anything. It doesn't mean there's anything wrong with your answer. You just have to be careful with the arithmetic. Use your calculator to help you. Okay? Give those practice problems a shot. Make sure you know how to do both kinds and come back for part 2 of 8.1.